Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 65. Today we will talk about volume problems. Where do we find volume problems? Well, volume has applications in many areas of science, including medicine, engineering, and even construction. For example, a chemist needs to accurately measure the volume of reactive substances. A doctor may need to calculate the volume of a tumor based on a body scan. Engineers or construction personnel would need to determine the volume of building supplies like concrete or asphalt. They might have to calculate the volume of a room in a completed building to determine the size of mechanical devices like an air conditioning unit. We're going to do 3 examples today. In our first example, we have this right triangular prism. We're given that the volume is 1,440 cubic centimeters. What is the height if we know that the triangle has a base of 8 and a height of 15? So our volume formula is the area of the base times the height of the prism. The area of the base is a triangle, so it's 1/2 base times height of the triangle. We know that the total volume is 1440. Our formula for the area of the base, which is the area of the triangle, is 1/2 8 times 15, and then we'll multiply by the height of the prism. 1/2 times 8 times 15 is 60. So we have 60 times h is 1440. We'll divide both sides by 60, and we'll get that h is 24. So the height of this prism is 24 centimeters. The volume of this sector of a right cylinder is 2,814 meters cubed. Find the radius of the base of the cylinder to the nearest meter. Again, our formula for volume is the area of the base times the height. Now this one, the area of the base is part of a circle. So remember how we find the part of the sector. We're going to use the fraction based on the angle of the part that we have, which is 40 degrees, and the entire circle would be 360 degrees. So this fraction will tell us that that's just part of the circle. Then we'll multiply by the area of a circle, pi r squared. And last, we will multiply by the height of the cylinder. And that is all equal to 2,814. So 2,814 is 1/9. That's 40 over 360 reduced. Times 3.14, that's pi, times 14, which is the height of the cylinder, and then our radius squared. We multiply this side together, or we can undo the equation. So we take the 1/9, we multiply 9 on both sides, then we divide by the 3.14 and divide by the 14. So over on this side, we would have 9 times 2,814 divided by pi times 14. That will give us our radius squared. So 575 is this side of the equation, and that's rounded, 575.8. And that would be r squared. So the last step would be to take the square root of 575 and the square root of r squared, which would give us r is equal to about 24 meters. Our last example is a little more practical. We have a child's wading pool with a diameter of 8 feet and it's filled to a depth of 18 inches. You want to keep this full for a few days, so you need to add chlorine at a rate of 1 tablespoon per 50 gallons. How many tablespoons of chlorine will you need to add? First, we need to calculate the volume. The volume is the area of the base times the height, because this is really just a cylinder. We have pi times r squared, which would be 4 since the diameter is 8. And then our height is 18 inches, but we need to put that into feet. So that's 1.5 feet. We have pi times 4 feet squared times 1/2 foot. So that volume is 75 about 4 feet cubed. But we need to calculate this in gallons, so we have to figure out how many gallons are in a cubic feet. There's 7.48 gallons in 1 cubic foot. So if we take our 75.398 and multiply it by 7.48, we get that we have about 564 gallons in this pool. Now we're going to divide that 564 by 50 because each 50 gallons only needs 1 tablespoon. That leaves us with 11.28 tablespoons of chlorine that's needed. And if you want to measure that in cups, you may need to calculate that there's 6 tablespoons in a cup. So 11.28 divided by 16 is about 0.7 cups of bleach. And you would need to add this about once a day.